projectile is fired from the surface of the earth with the velocity of 5 meter per second and theta with the horizontal. Okay, so we have fired at 5 meter per second, angle theta completes the projectile. Another projectile is fired from another planet. The moment we say another planet, what should we understand? That GE is equal to 9.8 and G of another planet, it may or may not be equal to the acceleration due to gravity on Earth. So considering another planet, it is launched at 3 meter per second with the same angle theta, completing the projectile. But here let us take this as G1 and this as G2. Okay, so we know that when we have a identical trajectory, what is the equation that we're going to use? It is very simple, and it is G by U square is equal to a constant, which means G1 by U1 square will be equal to G2 by U2 square. What is G1? Given to be 9.8. What is U1? It is given to be 5. So 5 square is equal to, what is G2? Is that we need to find out G2. What is U2? It is 3 square. So what is G2 is equal to? G2 is equal to 9.8 into 3 square is 9 upon 25. For the ease of calculation, I'm going to consider 9.8 roughly equal to 10. Okay, so we get 10 into 9 by 25. 5 5s are 25, 5 2s are 10. So this is 18 by 5, 5 3s are 15, 18 minus 15 is 3, 30 is 3.6, close to 3.6. Is there option? Oh yeah, yes. So we have an option A, 3.5. So again, it took me 2 minutes. I drew the diagrams and I wrote the entire formula. While you practice in the examination hall, it should just take less than 1 minute, because if you know this formula, it's just direct substitution, right? But now let us see, how did we arrive at this formula? So we know that the trajectory of projectile motion is given by the equation y is equal to x tan theta minus gx square by 2 u square cos square theta. Now we need to apply y in two cases, y1 and y2, where y1 is on Earth and y2 is on some other planet. But we've been given that the trajectory is identical, which means y1 is equal to y2 is what we have. Now what is y1? y1 is x tan theta minus gx square the whole upon 2u square cos square theta. So for the ease of understanding, let us take theta 1, tan theta 1. Now what is this equal to? This is equal to x tan theta 2 minus gx square the whole upon 2. So this should be u1 square, right? Yeah, 2u1 square and then 2u2 square into cos square theta 2. Now since both of them are launched at the same angle, we can say that theta 1 is equal to theta 2. Therefore tan theta 1 should be equal to tan theta 2. Therefore cos theta 1 should be equal to cos theta 2, which means x tan theta 1 is equal to x tan theta 2. Those two terms will get cancelled. So what else do we have? Minus gx square by 2u1 square cos square theta 1 is equal to minus gx square by 2u2 square cos square theta 2. Now if you see, cos square theta 1 and cos square theta 2 are the same. X square by x square is 1. So all what we are left is g by, in which case I should ideally be writing g1 and g2, right? g1 and g2. So we have g1 by u1 square is equal to g2 by u2 square. So this is how we arrive at the formula in a very algebraic manner. Okay, so yeah, okay, so that's it. So let's move on to the next question.